Y'all don't forget to go over and see the cats and the dogs after class over in the student lounge too. That's Susan and remind me your name. Melissa agreed to come in and take Susan's spot for me today, so I appreciate her. But yeah, go see the cats and dogs in the student lounge before y'all leave today. It's supposed to de-stress you for finals week. All right, number 94. We have 3 equations, 3 unknowns. And by the way, it takes 3 equations to solve for 3 unknowns. It's like if I said you went to Walmart and you bought 3 things, 3 items, and they added up to be $50, you could do that in so many different ways. You could buy something for $1 and $1 and $48, or $2, $2 and $46, and on and on and on. Even if I said 2 of the items cost the same. Well, there's still a lot of answers for that. The 2 and the 2 and the 46, or the 1 and the 1, the 48, and on I could go. Okay, so if you have 3 unknowns, it takes 3 clues. I would have to tell you one more thing about your purchases. And that's what's going on when you have 3 unknowns. 3 unknowns here, it takes 3 equations or 3 clues. Now on our last problems, we had 2 unknowns, so it only took 2 equations. And that's how it will be, so on and so forth. Some of you may have learned this in matrix algebra in high school. If you ever use the matrices on your graphing calculator, that is a method that you can use if you want to explore that on your graphing calculator, to just put in the coefficients and derive a matrix. We will not be going into that per se in here. I will be doing it just by the algebraic way of addition. So here's how you do it. Label these equations 1, 2, and 3, and you want to whittle this down so that you have 2 equations with the same 2 variables. So you want to, step 1, create 2 equations with same 2 variables. Okay, that's the big step.
Are you taking up like the papers for homework, or those notebooks?
I was going to take up the papers and we were going to grade those for points, so I'll just kind of look at your work to make sure you have that down. So and I will give you credit. Remind me to do so. All right, so you're going to create 2 equations with 2 variables. So look through your x, y's, and z's and think what looks like the easiest one to work with. And here, all of these are pretty reasonable. I mean, if one was like 192 and you had some weird 57 or something, but all these are pretty lame, tame numbers. So z looks the easiest to me though. Z and negative z is just ready to be added out. So I would add equation 1 plus equation 2. And I'm just going to visually look at it. The addition method, I can add and get 8x. The y's, 2y minus 3y is minus 1y. And then the z's drop out automatically without any manipulation, and negative 15 and 12 is negative 3. So I've created one of those equations. Well, let me call it equation 4 to give it a new number. So I've created a new equation that is missing z. Now I want to create another equation that's missing z from this addition idea. So I added 1 and 2, so now I add a different combo, either 2 and 3 or 1 and 3. Any different combo will do. Pick what looks easiest to you. So I'm going to say 2 and 3 because the signs are already different. I like that. If I times that by 4 all the way through, I'll have a negative 4z and a positive 4z, and z will drop out of that combo. So my goal is to create another equation missing z. So I'm taking equation 2 and I'm timesing it by 4.
So wait, why did you choose 2 and 3 again?
Well, really 1 and 3 wouldn't have been bad. You've got a 1z and a positive 4z, but I like 2 and 3 better because the signs are already opposite. I won't have to change the signs. I like that. Okay, so then timesing by 4 on each term. 4 times 5 is 20. 4 times 3 is 12. And 4 times that z, why we did this. And then 4 times the 12, 48. And then I'll add that to equation 3, which I don't have to change anything in 3. Then I can use the addition method and z will cancel out. So 20 plus 2 is 22 x's. Negative 12 and 1y is negative 11y. Z's drop out. 48 minus 15 is 33. That will be my new equation 5. So again, that's the key on these. To get rolling is you have to create those 2 equations that have the same 2 variables. Now that I've done that, equation 4 and 5 is what we just did a minute ago. I could just say, now do what you just did. Get 4 and 5 together and then eliminate either x or y or use substitution. Okay, everybody have that down? Because I'm going to erase and try to stay right here. All right, so I'm going to look now at equation 4 and 5, my two created equations. And I could divide by 11. This one's just asking to divide by 11 because everything's divisible by 11. If you wanted to do that, you could. You don't have to. I want to try to either get the x's to drop out or the y's. The y's will be easier, so I'm going to times the top one. Well, what would I need to times the top one by to make it cancel with this y? Positive. Actually, you need it to be a positive 11, so the negative 11. So it's the same sign right now, so you need to go actually a negative 11. Yeah, you want to make it a positive 11, which might be what you're thinking. So we need a negative 11 times each one of those to make this happen. So negative 11 times 8 is negative 88. Negative 11 times negative 1 is positive 11 for your y, and negative times a negative, a positive 33. Quadruple positive. It's understood. Then when I add down, negative 88 and 22 is negative 66. The y's drop out. 33 and 33 is 66. Then you can divide by what's with the x. X is negative 1. So once you get one of the values, x is negative 1, now we've got to find all of its counterparts. You need x, y, and z, an ordered triple, all three variables solved for. So we got x is negative 1. We need to know y. You can put this negative 1 in for x in one of this 4 and 5 equation, but you couldn't go all the way back to the big 3 variable equations. You're not ready to go there yet. So you got to work your way back up. So I take my x is negative 1, plug it into x in one of the 2 variable equations, and figure out y. So you do plus 8, negative y equals 5. Divide both sides by negative 1. I've got negative 5, negative y equals 5. When I divide by negative 1, there's the y value. Y is negative 5. So again, I found that by plugging in x is negative 1 for this x. Equation solve that. Y is negative 5. So I've got x is negative 1, y is negative 5. I still need to know what z is. So I'll go all the way up to my big equations now that have x, y's, and z's, and I plug in an x, a y, and I solve for z. And you could do that in any of these 3. So I'm going to use the first one. So I'm going to plug in x is negative 1, y is negative 5, and z is what I'm solving for. Negative 13 plus z is negative 15. Throw the negative 13 across. Z is negative 2. Now, to know for sure that I have found the right answers, you want to plug these into all of the 3 original equations. It should be the one point that solves all 3 equations. The one and only point that works in all 3. All right, so questions on that? Okay, number 95 says find the parabola, the equation of the parabola that goes through these 3 points. Now, this is new for us in that when we did lines, we did this a lot. We would be given 2 points on a line, and they would say find the equation of the line. All it takes are 2 points to get the equation of a line. But for a parabola, 3 points will do it. There's 3 unknowns. In a parabola, this is standard form for any quadratic equation, which graphs to be parabolas. Y equals ax squared plus bx plus c. You all know that from the quadratic equation. So there's 3 unknowns, a, b, and c. 3 unknowns to do the equation of a parabola. So they gave us 3 clues, 3 points on that curve. And so what we're going to do is we're going to create 3 equations out of these 3 clues and then do what we just did on 94. We have to do that again, sorry. but these clues, what you'll do is you'll plug this in. The -2 is an x value, the 5 is a y value. So you'll take the generic equation, plug in this x and y in that equation, and create 3 equations from that. All right, so the first one, again, 5 is the y value, so it goes over there. 5 equals, then a times x is -2, b times x is -2 plus c. So everybody see I've plugged in -2 for these x's and 5 for the y's. And that creates this first equation or first clue. Do that for each one of these. And then again on the last one, y is 4 and x is 3. So plugging in the x's and the y. And so it creates equation 1, 2, 3. 3 equations again. So just like we did on 94, a 3-variable, 3 equation. I could clean these up a bit. You know, right here where I have -2 squared, I could call that 4a. I'm going to do that. So the cleanup would be 5 equals 4a minus 2b plus c. This one's 0 squared. That zeros that out, zeros that out. So all I've got is c equals -5. So that's great, you know, because I know Samantha asked me about that. I think that's the one you meant. So that's just great, actually. It seems odd because the other ones you keep 3 variables, but this is actually great because it means now c is known. We don't have to solve for c. We got that. And the other one, okay, 4 equals 9a plus 3b plus c. So this is equation 1, 2, and 3 in its cleaner phase. Now, we're going to start with the idea, the last one though, but like I said, because of this, you know, like Samantha said, it's kind of messes this up or confuses it because it's not going to flow exactly the same, but it is going to be it's going to be a bonus here in just a minute because it's going to help us to simplify. But anyway, my goal when I have 3 equations, step 1 is to create 2 equations with the same 2 variables. So what I want to do is eliminate from 1, 2, 3 some combo, but I can't really use this one because it's not enough variables to work with it. So it'll be 1 and 3. I'll be adding 1 and 3 together so that either A or B drops out. Once A or B drops out, I can plug in what I already know C is, and I'll be able to solve this quicker. So again, 1 plus 3, I want to add equation 1 plus 3 so that some variable drops out. And I don't want C to drop out because I already know what C equals. That'll help me. So either A or B. So when I look at these two, I've got a 4A and a 9A. I could make those both 36s. I'm looking for a common multiple to use. Or I could use 2 and 3 and try to make those both what? What's the multiple that 2 and 3 both go into? So if you were going to aim for the B's, what would you try to make those equal? 6s. So you can make these both into 6s. So it's really the LCM, the least common multiple. What do they both go into? So you try to make both of these 6s. They're already opposite sign. That's good. So if I take equation 1 times 3 and equation 3 times 2, that will do it. So timing through by 3 makes equation 1 15, 12, 6, and 3. Equation 3, doubling it all the way through. Now when I add those together, the B's do drop out as I wanted. And I get a new equation. I'll call it equation 4 like I did before. When you create a new equation, you can label that with a new number. So that's equation 4. Normally, you would need to create another equation 5 that's also missing B. But because 2 is weird for us, you know, things dropped out, well, I can't really do that. But the bonus I told you is I don't need to because I already know C is -5, so I can drop C is -5 right there to my new equation 4. What is it? -5. C is -5, and I'll be able to tell what A is now. So 23 equals 30A minus 25. Equation solve that. 48 equals 30A. Sorry, I'm running out of the board here. Divide by 30. Dividing by 30 gives me my A value is 48 over 30, and then reduce that fraction. You can divide 6 into each one of those. 6 into 8, into 48 is 8, 6 into 30 is 5. So that reduces to 8/5. So A is 8/5. We're getting this in order. A is 8/5. Do I know B yet? I don't think I do. I don't know B, and I know C is what, -5. So all I need to do now is still figure out what B is. I've got my A value, I've got my C value. I could go up here to one of my bigger equations where I had A, B's, and C's, plug in 8/5 and -5. Let's say like this equation 1. Let's use equation 1. Equation 1 is 5 equals 4A minus 2B plus C. So now I can say A, I know is 8/5. I don't know B, and C is -5. And then solve that equation. To save time, I'm going to tell you the answer comes out to be, oh, you know what? I don't know yet. 95. Answer key says it should be A, so that means this must have been -9/5. So you can equation solve, then get B. So that means in your original quadratic equation, you know y equals A is 8/5 x squared, plus your B, -9/5 x, and then C, your constant, -5. So that is answer A on the study guide. Let's go ahead and pause it.